So we're going to create some compounds from atoms. So only given two atoms, we're going to create a stable compound that fulfills its octet. So in the first one we've got phosphorus and sodium. And what we need to do is look them up on the periodic table and see what valence they are in. And you can get that from the group number. So sodium is in group number 1, so we've got 1 valence electron. Phosphorus is in group 5, so it's got 5 valence electrons. So we have to decide then whether this compound is going to be an ionic compound or a covalent compound. Sodium is on the left side of the periodic table. It is a metal. Phosphorus is on the right side of the periodic table, a non-metal. So therefore we're going to have an ionic compound that's formed out of this. So there's going to be charges that are involved. No covalent bonding. We're going to have full-blown charges, and the ionic attraction of positive and negative charges makes the molecule. So now we have to decide what the charges are going to be. So on the left side of the periodic table, the metals tend to want to give off electrons and form charged cations, or positively charged molecules. So if I'm in group 1, like sodium, then I'm going to have a +1 charge associated with that. If I'm on the right side of the periodic table and I'm involved in an ionic compound, phosphorus, oxygen, or nitrogen, or fluorine, then it wants to gain electrons. It wants to fill up its octet so it has a stable orbital. Phosphorus has 5 electrons already in its valence shell, in its outer shell. It wants to gain 3 more. So if we were to form an ion from phosphorus, it would be phosphorus 3-. So now we need to make a compound out of this, a stable compound. In order for that to happen, I need them to be neutral. The positive and the negative have to add up together to give essentially 0. So what I need to do then is figure out how many sodiums have to come together with how many phosphorus atoms to create the neutral molecule. Now from looking at it, I have a total of 3- charge on the other side, on the negative side, and on the positive side I only have a +1. So I'm missing 2 positive charges, meaning I'm missing 2 sodiums. So if we add in 2 more sodiums to this, and so a total of 3 sodiums, I can actually create a molecule that is sodium phosphide. So 3 sodium molecules, atoms combined together with 1 phosphorus atom to create a stable electrically neutral compound that is the proper molecular formula. To name this then, I know that the sodium atom has only 1 defined charge, and the phosphorus, being an ionic compound, part of an ionic compound, also only has the 1 charge on it as well, the 3-. Even though on the periodic table phosphorus shows many other types of oxidation states, when it's involved in an ionic compound, it really only deals with the -3 oxidation state. So it depends on what it's attached to. In this case, it's an ionic compound. So to name this, we know that the first atom is a sodium atom, and the second atom is phosphorus, but instead of calling it phosphorus, we're going to call it phosphide. So this is now sodium phosphide. We move on to the second set of atoms, with phosphorus and chlorine. So we look up on the periodic table. Chlorine's in group 7, so we have 7 valence electrons. Phosphorus is in group 5, we have 5 valence electrons. And now we need to make a compound out of them. So what we need to do is realize, are they both on the right side of the periodic table, or is it a metal and a non-metal combination? We know that they're both on the right side of the periodic table. They're both non-metals. This is going to be a covalent compound. We're going to share this, share electrons, and we're going to show bonds involved in this compound. In the sodium phosphide, we would not show bonds. We would not show, for example, sodium bound to phosphorus. This implies right here that there's a sharing of 2 electrons. That is not the case with an ionic compound, but with a covalent compound, we are going to see that. So starting with phosphorus in the middle, we're going to have a phosphorus atom, and we're going to put the 5 valence electrons around it. So now I'm going to put 1 chlorine atom down here, put the 7 valence electrons, and we can see that I can share and create 1 bond here. But this fulfills the octet for chlorine. I've got 1, 2, 3, 4, 5, 6, 7, 8 electrons total. 8 electrons total around chlorine. But the phosphorus atom is not fulfilled yet. And so we're going to need to add another chlorine atom in and keep going. So one more bond right there, and another chlorine atom over here. And now I can fulfill the octet for phosphorus. So phosphorus now has 2, 4, 6, 8 electrons around it. And I'm pointing now to the bonds that are involved. I can redraw this phosphorus atom, showing the bonds. Each one of these bonds represents 2 electrons that's being shared by phosphorus, and a lone pair of electrons that sits up top. We need to keep those in there. It actually tells us the shape of the molecule. It also tells us how many electrons total are in the system. So if we count up, for phosphorus we have 5 valence electrons. For chlorine we have 7, but there's 3 of them, so there's 21 electrons total from chlorine, 5 from phosphorus. 26 electrons. I need to have 26 electrons in my system. So let's make sure that we've drawn in all of the non-bonding pairs for each one of these atoms, and we count them up. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm missing some. Let's try it again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 electrons. So there's 26 electrons in the system overall. Now we'll try the last compound. We're dealing with a metal on the left side of the periodic table and a non-metal on the right side of the periodic table. So it looks like we have an ionic compound. Potassium is in group 1. So we know that we're going to have a +1 charge on potassium. And if we look at selenium, selenium is in group 6, meaning it's got 6 valence electrons around it. So if it wanted to fulfill its octet, it would want to gain 2 more electrons around it, meaning it would have 2 extra electrons. It would have a 2- charge. So anything in group 6 is going to have a 2- charge. So we want to form a compound between the metal and the non-metal, and when we're doing this, we always have the metal go first. So we're going to have potassium first, we're going to have selenium second. We have a 2- charge on selenium. We have a 1+ charge on potassium. It means we need 2 potassiums in order to balance out the selenium ions.